So Bryony suspects that a particular six-sided dice is biased in favour of 2. She plans to throw it 35 times and note the number of times it shows a 2. She will then carry out a test at the 4% significance level. Find the rejection region for the test. Okay, it's a hypothesis test. We know 7 marks. We know basically where the marks are going to be for this, and we know what we need to say. So we need to state the null hypothesis. Now it's the probability of rolling a 2 that we're interested in, aren't we? That's the bit that she's testing. So that we're going to say P is 1/6. That would be that it's an unbiased dice. And H1 is that P is greater than a 1/6. She wants to know, is it biased in favour of 2? So that's the bit that tells you that it's got to be greater than when you set that up. We would get 1 mark for this because we haven't defined P. So where P is the probability of rolling a 2 of scoring 2 on 1 roll. So we have to define what we meant by P. Right. The next thing, if we remember through from last year what our steps are that we go through, we're now going to say that X is going to be the number of 2s, because that's what she's going to count, isn't it? And X would follow a binomial distribution, because it's either a 2 or it isn't. There are 35 throws, and the probability of a success under H0 was 1/6. So that's that.
Do you get mark saying X is the number of 2s?
No. The mark there was for saying X follows the binomial distribution. Okay. Now we want to establish the value that we want. What we're looking for is the probability that X is greater than some particular value has got to be less than 0.04. This is going to help us to establish the reject region as we talk about this. When we deal with binomial, we normally do less than or equal to probability, so I'm going to work out, the calculator does above, doesn't it? I'm so used to doing this the way that we used to do it with the tables, that the calculator does both ways, doesn't it, for binomial?
No.
Does it only do less than or equal to? Okay, so we still want to do that. So we're going to do that as being 1 minus probability that X is less than or equal to K has got to be less than 0.04. So that means the probability that X is less than or equal to our particular number has got to be more than 0.96. If I rearrange it, it's 0.96 that I'm looking for in all of this. I need to test some of these out. So I'm going to think, how many do I think is likely? Well, it's 35, isn't it? So a 1/6 of 35 is around about 6. So it's going to be more than 6 that I'm looking for. So I'm going to start trying a few values. I'm going to try 9. Probability that X is less than or equal to 9. On the calculator, let's see if I can remember how to do this one now. So this is a binomial cumulative distribution. I could do a list on this one, couldn't I? And do X as being what, 6, 7, 8, 9, 10, 11. Let's do a few of them, and let's put in that as being 35 and 1/6. And it should give me the probability. So it's got a probability for 9 as being 0.9449. For 10, it's given me 0.9768. What was that I just got? 9768. Okay. That's the crucial point, because 0.96 lies between those two values. is in between those two values. Therefore, k equals 10. So x has got to be greater than 10, and the reject region I am rejecting every value x greater than or equal to 11. We normally take a reject region as being including the first number that we would reject, and that's it. That was all that we were saying, and that's maths.